What if I told you that the solar system isn't just a collection of planets? It's a collection of entire worlds, each with its own personality. Some are hot enough to melt metal. Some are covered in ice so cold it behaves like stone. Some are giant balls of gas with storms bigger than Earth. And some, like our moon, look quiet on the surface but hide clues about the violent history of the solar system. So what actually makes every planet and moon unique? And more importantly, why does that matter to us? The answer starts with three big factors: what a world is made of, how far it is from the sun, and what happened to it after it formed. Think of the solar system like a giant construction site. The materials that formed closest to the sun were mostly rock and metal, because it was too hot for lighter stuff like water and gases to stick around. That's why Mercury, Venus, Earth, and Mars are rocky planets. Farther out, where it was colder, ices could survive. Water, ammonia, methane, that extra material let planets grow much larger. That's how we got the gas giants and ice giants: Jupiter, Saturn, Uranus, and Neptune. But distance from the sun is only the beginning. A planet's gravity determines what it can hold onto. Small worlds like Mars lost much of their atmosphere because they didn't have enough gravity to keep lighter gases from escaping into space. Bigger worlds could hold on to thick atmospheres, and some even captured huge envelopes of hydrogen and helium. Then there's geology, the hidden engine inside a world. Earth has plate tectonics, which recycle the surface, build mountains, and help regulate climate. Mars, on the other hand, cooled down faster and became geologically quieter. That's why it has giant volcanoes and ancient dry valleys, but not the same kind of active surface recycling we see on Earth. Moons can be just as surprising. Take Jupiter's moon Io. It's the most volcanically active world in the solar system, not because of sunlight, but because of gravity. Jupiter's enormous pull constantly flexes Io like a stress ball, creating heat through tidal forces. That internal heating melts rock and powers volcanoes. Now compare that to Europa, another moon of Jupiter. Its surface is covered in ice, but scientists think there's a salty ocean underneath. Again, tidal forces are the key. Jupiter's gravity may be keeping that hidden ocean liquid. This matters because once you understand what shapes a world, you can start predicting what's happening on worlds you've never visited. If a planet is small and far from its star, you might expect a frozen, inactive surface. If it's large and close in, it may have a thick atmosphere or extreme temperatures. If a moon orbits a giant planet closely, tidal heating might make it geologically active, or even capable of supporting an ocean. That's not just cosmic trivia. It's how scientists search for habitable worlds. For example, when researchers look at exoplanets, planets around other stars, they ask questions like, how big is it? How close is it to its star? Does it have an atmosphere? Could it have liquid water? Those clues help narrow down which worlds might be rocky, icy, stormy, volcanic, or potentially alive. Mercury is small, rocky, and scorched by the sun, with huge temperature swings. Venus is almost Earth-sized, but its thick carbon dioxide atmosphere creates a runaway greenhouse effect, making it the hottest planet. Mars is cold and dusty, with evidence that water once flowed on its surface. Jupiter is a gas giant with no solid surface you could stand on. Saturn is famous for its rings, but those rings are made of countless icy particles. Uranus and Neptune are ice giants, rich in heavier volatile compounds. And moons like Titan have thick atmospheres, while Enceladus sprays water vapor from cracks in its icy shell. So the solar system is not just a lineup of spheres in space. It's a record of temperature, gravity, chemistry, and time. Every planet and moon tells a different story. Some are frozen, some are molten, some are hiding oceans, and some are shaped by forces we can barely imagine. And that is what makes them unique. Not just what they are, but the physics that made them that way. If you know the rules, you can start reading the worlds. And once you do, the solar system stops looking like empty space and starts looking like a living story. From rocky to icy, what makes every planet and moon unique is just one small part of the solar system: planets and moons. If you are interested, our full free course, The Solar System, Planets and Moons, is linked in the description.